Welcome to the Fox Learn. Current use comes from the work of the architect Christopher Alexander. Alexander studied ways to improve the process of designing buildings and urban areas. Each pattern is a three-part rule, which expresses a relation between a certain context, a problem, and a solution. Hence, the common definition of a pattern, a solution to a problem in a context. Patterns can be applied to many different areas of human endeavor, including software development. Designing object-oriented software is hard, and designing reusable object-oriented software is even harder. Eric Gamma. Experienced designers reuse solutions that have worked in the past. Well-structured object-oriented systems have recurring patterns of classes and objects. Knowledge of the patterns that have worked in the past allows a designer to be more productive and the resulting designs to be more flexible and reusable. In 1987, Cunningham and Beck used Alexander's ideas to develop a small pattern language for Smalltalk. 1990, the Gang of Four, Gamma, Helm, Johnson, and V. Lisides, begin work compiling a catalog of design patterns. 1991, Bruce Anderson gives first patterns workshop at OOPSLA. 1993, Kent Beck and Grady Booch sponsor the first meeting of what is now known as the Hillside Group. 1994, First Pattern Languages of Programs, PLOP, Conference. In 1995, the Gang of Four, GOF, publish the Design Patterns book. Analysis. Design. Organizational. Process. Project planning. Configuration management. Rila and Zollaghoven in Understanding and Using Patterns in Software Development mention three types of software patterns. Conceptual pattern, pattern whose form is described by means of terms and concepts from the application domain. Design pattern, pattern whose form is described by means of software design constructs, such as objects, classes, inheritance, and aggregation. Programming pattern, programming idiom pattern whose form is described by means of programming language constructs. Complex design for an entire application or subsystem. Solution to a general design problem in a particular context. Simple reusable design class such as a linked list, hash table, etc. Design patterns are solutions to software design problems you find again and again in real-world application development. Patterns are about reusable designs and interactions of objects. A design pattern names, abstracts, and identifies key aspects of a common design structure that makes it useful for creating a reusable object-oriented design. The GOF design patterns are in the middle of these levels of abstraction. The GOF design patterns are descriptions of communicating objects and classes that are customized to solve a general design problem in a particular context. The 23 Gang of 4, GOF, patterns are generally considered the foundation for all other patterns. They are categorized in 3 groups: creational, structural, and behavioral. Purpose: what a pattern does. Creational patterns concern the process of object creation. Structural patterns deal with the composition of classes and objects. Behavioral patterns deal with the interaction of classes and objects. Scope: what the pattern applies to. Class patterns focus on the relationships between classes and their subclasses. Involve inheritance reuse. Object patterns focus on the relationships between objects. Involve composition reuse. Pattern name. Having a concise, meaningful name for a pattern improves communication among developers. Problem. What is the problem and context where we would use this pattern? What are the conditions that must be met before this pattern should be used? Solution. A description of the elements that make up the design pattern. Emphasizes their relationships, responsibilities, and collaborations. Not a concrete design or implementation, rather an abstract description. Consequences. The pros and cons of using the pattern. Includes impacts on reusability, portability, extensibility. Pattern name and classification. A good, concise name for the pattern and the pattern's type. Intent. Short statement about what the pattern does. Also known as other names for the pattern. Motivation. A scenario that illustrates where the pattern would be useful. Applicability. Situations where the pattern can be used. Structure. A graphical representation of the pattern. Participants. The classes and objects participating in the pattern. Collaborations. How do the participants interact to carry out their responsibilities? Consequences. What are the pros and cons of using the pattern? Implementation. Hints and techniques for implementing the pattern. Sample code. Code fragments for a sample implementation. Known uses. Examples of the pattern in real systems. Related patterns. Other patterns that are closely related to the pattern. An important part of each pattern's description is a unified modeling language (UML) class diagram. UML is a universally accepted way of describing software in diagrammatic form. There are three kinds of blocks, 4 classes, interfaces/abstract classes, and packages. The class is the most common diagram element and contains details of some of its corresponding C# classes' more important attributes, or fields, and operations, or methods. A UML diagram is not meant to be an exact copy of a program, and thus only the elements that are important to the pattern under consideration are shown. The accessibility of all attributes and operations, private, public, or protected, is indicated. The default for attributes is private and for operations is public. Deviations from the defaults will be highlighted as they occur. The types associated with attributes and operations are not usually given. However, when these are important, they can be inserted after the identifier, separated by a colon. The same relaxed approach applies to parameters of methods, which are not usually shown in a diagram. Notes are very useful for explaining relationships, such as when a method in one class calls a particular method in another, when this information is directly relevant to the pattern. In most cases, though, 6 types of lines give enough information. Capture expertise and make it accessible to non-experts in a standard form. Facilitate communication among developers by providing a common language. Make it easier to reuse successful designs and avoid alternatives that diminish reusability. Facilitate design modifications. Improve design documentation. Improve design understandability. Thank you for watching this video.